Okay, we'll get started. So I was starting to get things together for the final, and I was also looking at the stuff from Chapter 7, Chapter 8 that we could cover today. And as I was putting things together for the final, I was like, God, that is a lot of material. So what we're going to do is just, all this week is just review for the final. That's it, okay? I've typed up a review, or I have a review. I've kind of borrowed some stuff from some other faculty. And I have a 50-question review that I thought we would work through this week. And basically, if you're comfortable with that material, you're going to be fine for the test. My goal is to just kind of pick problems from this review, tweak the numbers a little bit, and present that to you as the final. So no surprises or anything like that, but you need to be comfortable with this material, okay? So 50 questions is going to take us quite a bit of time to get through it. The stuff that we covered in Chapter 8 in terms of like sets and intersections and unions and all that stuff, I will put something like that on the final, but it's not on this review. We'll talk about that on Thursday, all right? And my camera is back in service, so this will all be online. We good? Put a couple of extras here just in case. All right, so what I would do here is, you know, as I work through these problems, I will be moving kind of quick, but, you know, stop me, and, you know, if you have any questions, let me know, right? Then I would go home and I would look in your book in the exercise sets if you want to do additional practice and just find problems that kind of match up with these, all right? Y'all ready? I know it's Tuesday, kind of feels like Monday, the weather, we don't want to be here, but it's just the way it is.
Are the solutions going to be on Canvas?
Solutions I'm going to do right here on camera.
But we're going to do all.
I hope so. Yeah, that's why I want to shut up and start doing math here. So we good? I'm going to start with number 1. So number 1, the instructions are to subtract. So looking at that, what do I need to do in order to do this subtraction? What's the key fundamental principle of this problem? And why would I ask something like this on a final? I'm asking you to subtract. Yeah, the main thing is, you know, how do you deal with this minus sign in front of something that's in parentheses? You just got to remember, distribute that negative through. Now, how about the parentheses on the first expression? I can just drop them out because there's not a negative in front of it, so I can just drop it. You can look at it as like a 1 in front. All right, so I can rewrite this as 6x squared minus 4x plus 2. And then distribute your negative sign through, and it changes it to minus 5x squared minus x, what? Plus 8. So that's equal to this. And now you just collect like terms. So how many x squareds do I have? Just 1x squared. How many x's? Negative 5. And then how about my constant, my number that doesn't have x's? Plus 10. Okay? Box it up, and we move on. Look at that. We're already through the first one. It took us a minute. Now, some of these are very long. So number 2, part A. The instructions here are to what? Factor. Okay? So this is where you know, depending on your background, I've been saying this since day one, everyone should be able to factor this. But I will go ahead and go through the process of factoring this one. The method that I showed you is you create this little x, because it's 3 terms, right? There's no greatest common factor here. So we can't pull a number out, we can't pull a variable out. So 3 terms, we go to this AC method, and what numbers do I put in here? Negative 36 goes up here, and then here, negative 5. Okay, so you're taking the number in front, 1, you're multiplying it times this number, and then that goes here, and then you're taking this number and you place that there. Okay, now you have to, either on your calculator or in your brain, come up with 2 numbers that multiply to be negative 36, but add up to be negative 5. 9 and 4, but how do you mean? Negative 9, positive 4, right? These multiply to be negative 36 and add up to be negative 5. Now, the way that I've shown you to do this, way back when, is that you rewrite this, and you rewrite the negative 5x as negative 9x plus 4x minus 36. So that's the way the method goes. So that's what I'm showing you. You can go a little bit shorter. You could just write x minus 9, x plus 4 in parentheses. But the only reason that works, does anyone know the only reason that works, that you can do just do x minus 9, x plus 4? Because there's a 1 here. If this is something other than a 1, you can't do that. You have to do this method. So I'm going to continue with this. Okay, so here I have 4 terms now. Everyone understand I rewrote the negative 5x like this, using these 2 numbers. Now, I split it into 2 sections, and I pull a greatest common factor out of the first expression. So what can I pull out of here? X, and that leaves me with an x minus 9. Now I need to pull something out of here that's going to leave me with x minus 9. So what can I pull out of here? These 2. What do they have in common? 4. So I pull a positive 4 out. That leaves me with x minus 9. So if I distributed this back through, I'd get this. Since these 2 match, my next line is what matches, and then the coefficients in front of these parentheses, so x plus 4. Look, again, this is factoring. This is, if you're going to go on and take 1325, I guarantee you will not spend time doing this at all. Okay, it'll go from here to here, and that's it. That'll be the expectation. So, all right, number 2, part B. Okay, for 2B, you're asked to factor. What's the big difference between 2A and 2B? You don't have the 3 terms. You only have 2 terms, right? So do you have a greatest common factor, something that can come out of that? No? So what's really your only method? That's a special formula. Difference of squares. That's the difference of squares formula. So we're going to write 2 sets of parentheses, and then it'll be x minus 8, x plus 8. Done. All right, moving on. Number 3. Want to solve this linear equation? Oh, I gave it away already. It's a linear equation. How did I know it was a linear equation? What's the highest power of x? 1. Okay, if it's 1, then it's a linear equation. For those of you who are just coming in, I have a 50-question review for the final exam that I'm working on that I'm going to work through the next 2 days. Is there an extra one there? No. This will be our preparation for the final, which I believe is on, is it Thursday? Okay. All right, so now what? What do I do if I'm going to solve this linear equation? Yeah, I'm going to have to get x by itself on one side of the parentheses. So I've got to clear all those parentheses out. X on one side of the equation. So I've got to get rid of all the parentheses first. So I'll distribute a 2 through here. a -8 through here, a 6 through here, and then I'll see what I've got after that. So on this, just take your time, make sure you're thinking through your arithmetic. That should be right if you distribute through. Sorry, I shouldn't have put this equal sign over here. All right, now what? Collect like terms. So on the left side, put all your x's together, put all your numbers together. So how many x's on the left? 2x. And then what about the number? Minus 36. Must equal, right side, collect like terms. 14x plus 24. Okay, now you're going to get all your x's on one side, anything that doesn't have x on the other side. So which side would you like to move the x's to? Left. It's your choice. You can't get it wrong by doing it one way over the other. It's your choice. So you want the x's on the left? That means I'm going to have to subtract 14x on the right side, subtract 14x here, and I'll go ahead and do that line right now. What's 2x take away 14x? Negative 12x. What do I still have over there, though? Minus 36 equals, what's my right side? 24. Okay, now, trying to get this term by itself. So I need to get rid of the 36, so I add 36 to both sides, right? And you still have negative 12x, and then equals, this is 60. All right, last step, what? Add 12 to both sides? Divide, right? Because it's multiplication. We're going to divide negative 12, divide negative 12. Remember, you have to divide by a negative so that it becomes positive, right? So this is just x, and then what's that? Negative 5. Okay, it's number 3. Number 4. Solve the inequality. Write your answer in interval notation. I don't know. It's number 4, not number 5. All right, so 5, parentheses, 3x minus 4, and then less than or equal to 100. So what can you do here? You want to distribute the 5 through? Yep, we can do that. Okay, 5 goes through there. We get 15x minus 20, less than or equal to 100. So far, everything's good. Now, like terms, which we don't have any. So, what? You want to take care of that? Negative 20, we're going to add 20 to both sides. So we're doing it pretty much like a linear equation, right? Does anyone remember the one thing you have to be really careful with inequalities? Yeah, you flip this over if you ever divide by a negative number or multiply by a negative number on both sides. In this case, it's not going to happen, though. We're going to have 15x less than or equal to 120. At this stage right now, to get x by itself, I'm going to divide by 15, right? Had that been a negative 15, I would have divided by negative 15 and flipped the inequality over. That's what I'm saying. That's the big thing you have to be careful with inequalities. So divide by 15, divide by 15. X is less than or equal to 8. Okay, now that's not the answer because it says it wants your answer in interval notation. So interval notation, if you remember, is you draw a number line. Here's 8 on that number line, and you want all the x values that will be, what, bigger than 8 or smaller than 8? Your x's are smaller than 8. So it's everything to the left of 8, including 8 or not? Yes. So you either do a solid dot or a bracket, however you want to look at it. Now, how do I write that as an interval? Everything to the left of 8, but including 8. Negative infinity to 8, bracket on the 8, and always a what on infinities? Parentheses. That's the answer right there. Okay, so you give me this answer, I'm going to give you 8 out of 10 points, right? Give me that answer, you get 10 out of 10 points. So be careful, if it asks for interval notation, give me the interval notation. Questions? All right, 5. A. Write the correct intervals for each of the following statements. Use interval notation or set builder notation, your choice. So we did mostly interval notation in here, right? So what about A? A profit occurs when the number of items X produced and sold is between 134 and 361. So it's saying, like, you know how this said all the answers are less than or equal to 8? Here it's saying all your answers are between 134 and 361. So how do I write that? All the answers are between 134 and 361. Everything in here, right? Including or not including? It says between, right? We would interpret that as between them, not them, those numbers themselves. So we leave this open like this, or you could do the parentheses. So how do I write that as an interval? 134, comma, 361, parenthesis, parenthesis. Part B says a loss occurs when the number of items X produced and sold is between 0 and 134 and when X is above 361. So this is saying if you're between 0 and 134 or above 361. So between here or above 361. So how would I write that? 0, so I can go parentheses 0, 134, parenthesis, then this one. 361, 361, then what? What do we mean 361 forever, the rest of the way? To infinity. And then parenthesis on those. And then what do I always put between two sets when I'm using interval notation? Remember that? Remember that symbol? Union? We actually use this symbol in the last few classes now, but you can see where it comes from, right? This set together union with this set. Okay, if you were to have used brackets on these, I probably would not take off anything because really the interpretation of the wording is a little vague there. So if you had brackets on this, this, and this, I'd be okay. All right, moving on. I'm trying to move quick because some of these problems take quite a bit of time. I'm trying to give myself enough time. I only have, what, an hour and 15 minutes today, hour and 15 minutes on Thursday, so 2.5 hours to do 50 problems. That's a lot of work. So let's see. Number 6. Sketch the graph of 2x plus 7y equals 14. All right, if I'm going to sketch that, go ahead. What?
That time number, it's like the x and the y columns. Is it that?
X, like a t-table?
Yeah, a t-table.
You could do a t-table. What type of equation is this, though? It's a linear equation, right? You know it's linear because it has two variables, x and y, and they're both to the first power. So this is a line. So we have a couple of options. We can solve this for y and make it look like this. Y equals mx plus b, and use the points, the intercept, slope intercept, or we can just find the x-intercepts and y-intercepts of the line. So there was kind of two methods with this. What do you want me to do? You want me to do both or just one over the other? Don't care. All right, let me do this way first. And then personally, I would not do this way for this particular problem, but let's just do it. Okay, if I solve this for y, I have to move the 2x to the other side, so it becomes a negative 2x, right? And then I have to divide both sides by 7. So divide this by 7, it's gone. Negative 2/7 x here, plus 2. So divide that by 7, you get this. Divide this by 7, you get this. Divide this by 7, you get this, right? Yes, yes?
Yes.
Okay. Now, from here, what I can do is I can start graphing by first plotting a point. Where's that point going to be? 2 where? Up 2 on the y-axis. And I'm getting that from this point right here. So I go up 2, and I put a point there. That's 1 point on my line. Where's the next point? How can I get it? Down 2, over to the right 7, using the slope, right? The slope tells you, you can write that as negative 2 over 7. Down 2, right 7. So from here, if I go down 2, 1, 2, to the right, 1, 2, 3, 4, 5, 6, 7, to 7, here's 2, and put a point, then I know it's a straight line, so I can connect the 2 points, and I'm done. Okay? That's using the method of putting it in what we call slope-intercept form. The other option would have been to find the x-intercepts and then find the y-intercept. How do we find x-intercepts? Set y to 0. So you take the equation 2x plus 7, you replace y with 0, right? And then you get, what, 2x is 14? Divide both sides by 2, x is 7. So that means 7, 0 is a point on my graph. I plugged in 0 for y, it gave me 7 for x. Does this look familiar? Okay. Y-intercept, how do we find y-intercepts? Set x to 0. So we go back to the equation. We replace x with 0. And that just gives you 7y is 14, which means y is 2. So that means when x is 0, y is 2. So I have 2 points, don't I? And I plot them. And I draw a straight line between them. And notice in this particular problem that these 2 points are actually these 2 points, aren't they? It's 0, 2, and 7, 0 right here. We would actually draw the same line if we did this. Doesn't matter which way you do it. I mean, we're going to draw the same line no matter what. But we happen to get the same points. We good? Okay. Number 7. We can do a little music background, little background music. That's fine. All right, 7a. It says here, find the domain of each of the following. Write your answer in interval notation or set builder notation, your choice. All right, so your first one, g of x equals 8x squared plus 2x minus 25. 5, yeah. All right, so when we're talking about domain, we're saying what values of x are you allowed to plug into this? Another way you could look at these problems is by asking the question, what values of x can you not plug in, right? So is there anything that I cannot plug into this? Well, what are the things we look for that cause problems? Division by 0 and roots of negative numbers. Those are the main issues in a class like this. So do you even have a fraction? You don't even have fractions, do you? You don't have any square roots. This is a nice polynomial function, and when we graph it, remember it's a parabola? This is a parabola, right? And so it goes both directions forever, so there's no domain issues. So the domain is everything. So how do we say that? Like you can plug any x you want. You can do it in interval notation, it would be like this. That would be your domain. I will accept, if you write down all real numbers, I'll accept that even though it says interval notation. I will also accept that double struck capital R for all real numbers. What about for part B? Capital H of x is 9 over the square root of x minus 3. Ooh, this one's a little bit tricky. We have kind of a double whammy in this problem. We have the possibility of division by 0. And we have a square root, so we could possibly have to get negatives under there, which would be bad. So what can you tell me about this expression, x minus 3? What about that expression? What does it have to be? Can it be negative? Can this be negative? What I've circled in red? No, because I can't take the square root of a negative number, right? So this thing has to be positive. Do you agree?
Yes.
Can it be 0? Well, can you take the square root of 0? Yes, the square root of 0 is 0, okay? But the problem with that is that if this red thing is 0, we're dividing by 0. Do you see that? So this red thing has to be not only positive, it cannot be 0, right? So how do we write that down algebraically? We say, hey, that thing x minus 3 must be greater than 0. 0. The whole expression, you're already there. You're already at the answer, okay? I'm saying that whole expression has to be positive for this to work. Now add 3 to both sides. X has to be bigger than 3. Okay? Yes? So x must be bigger than 3. Now that's not the answer in interval notation. In interval notation, this would be 3 and everything bigger, not including it, right? So what's that written in interval? Parenthesis, 3, comma, infinity, parenthesis. Okay? Questions? This is your opportunity. C of x equals 6x plus 1 over x minus 8. Okay, do we have potential problems here? We have a fraction, don't we? So what would make us have division by 0? What value of x would you plug in that would cause a problem? 8, right? If x was 8, think about that, right? If x was 8, 8 minus 8 is 0. Now, we do not have a square root this time, right? So we don't have to worry about it being positive or negative. We don't care about that. We just don't want it to ever be 0. Agreed? So what we're really saying here is that the x can't be 8, right? We want to say x cannot be 8. Anything else will work, okay? We just cannot have 0 down here. Can you have 0 up here? That's okay. It's okay to have 0 on top. You just can't have the 0 on the denominator. So how would I say this? Here's 8, right? We don't want 8. How about to the left? Is it okay to have stuff over here? Yes? How about to the right? Yes. So how do we write that in interval notation? Everything to the left of 8, everything to the right of 8. Without, no, but in interval notation. So how can you say everything to the left of 8 not including 8? Negative infinity to 8 not including it, right? How do you say everything to the right of 8 not including it? 8 to infinity, like that, right? And in between them, a union. So this takes all the numbers to the left of 8, kind of jumps over 8, and then everything after 8. All right? Still on number 7, part D. F of x, giving you this function here, x squared plus x minus 12. All right, again, there is a possibility that we could get division by 0 here, right? If I pick the right x, this thing down here might be 0. So you need to ask yourself that question. What makes that 0? Because you don't want that to happen, right? This is the question. What makes that 0? So how are you going to solve that equation there? What can you do on the left side? Factor it. You could factor this. Now I'm not going to take the time to show how this factors, but it's plus 4 minus 3. Okay, so if you factor this left side, you get this. And now set each of those equal to 0. So if you set x plus 4 equal to 0, you get something x minus 3 equal to 0. Should get negative 4 and positive 3. Agreed? Now, keep in mind, we actually don't want these, right? We don't want these. Because these are what makes our denominator 0. And that causes a problem for this function. So we need to keep that in mind. We don't want this happening, right? And we want our answer in interval notation. So draw a number line. And keep in mind that that number line, we want everything except negative 4 and except 3. We don't want those. So we want everything over here, everything in between, and everything to the right. So how many intervals will I need to do this? 3 intervals. What's this interval right here? How do I write that interval? Everything to the left of negative 4. Negative infinity to negative 4, parenthesis, parenthesis, right? I'll go ahead and put the union now. Union, now, what about this middle interval? How do I write that? Negative 4, comma 3, like that. And then jump over 3 here, so union again now. 3 to infinity. All right, 10 o'clock. Number 8. Find the difference quotient. All right, now the difference quotient is not on this page. I am going to allow you to have a reference sheet that you may create for the final that can have any formulas and steps and procedures. You just can't work out problems, all right? There will be no penalty for having that on the test. One sheet, front and back, all right? So I would write down the difference quotient formula if I were you. The difference quotient formula is f of x plus h minus f of x all over h. That's your difference quotient. Y'all remember doing this?
Yes.
Okay, so we have to figure out top left, top right, bottom, right? So let's figure out what f of x plus h is first. What would f of x plus h be if this is the function that's given to us? So we replace all of our x's with x plus h's, right? Like that. So I replace every x with x plus h. And then I actually have to do the math here. I've got to expand x plus h times x plus h, distribute a negative 2 through, and don't forget there's a 5 out front here. So I'm going to go ahead and do that. If I were to take that and square it, that's what I would get. I have to do like a FOIL, and then I collect like terms together, and I would get, that's what I would get if I squared that. But there's a 5 in front of it. So okay, that's just this piece. Then minus 2x minus 2h plus 6. Distributing the negative 2 through. So I should have here 5x squared plus 10xh plus 5h squared minus 2x minus 2h plus 6. That's f of x plus h. That is only this top left corner, right? Then I have to subtract from that f of x and then divide by h. So I'm ready to come do the difference quotient now. All right, that was just my scratch work on the side. So this difference quotient, this, is equal to 5x squared plus 10xh plus 5h squared minus 2x minus 2h plus 6. And then I'm going to subtract from that f of x. And what do I need to do with this? Be careful. I'm going to subtract f of x. This is what I'm subtracting. So I need to either put it all in parentheses or distribute the negative right now. So do you want me to distribute the negative now or write it in parentheses? Do it now. So this is going to be minus 5x squared. Then what? Not minus 2x, but plus 2x. And not plus 6, but minus 6. Understand? Yes? No? Yeah? All of this divided by h. And what am I hoping for? Something should happen here. We should get a bunch of stuff to cancel, and the only thing left should have h's in it. Does this bother you, this thing? 1325. Math 1325. We're going to do this for a long, we're going to do this a lot. Okay? So that's why we introduced it in this class. So when we get to 1325, it's not like, oh, I've never seen that. Okay? All right, so look, cancel 5x squared, 5x squared. What else? Negative 2x plus 2x plus 6 minus 6. I don't think anything else cancels. So what we're left with is 10xh plus 5h squared minus 2h, right? That's the only thing left on top. And on the bottom, an h. And remember, I said we're looking for something where we just have h's in everything. So what you can do now is you can factor an h out on top, just one h. So I pull a single factor of h out of each of these. And now these h's cancel. And your final answer is what was left there, 10x plus 5h minus 2. How many of y'all plan to take 1325? Yeah. Okay, so look, I'm going to show you something real quick. See this problem right here? That's really x to the first power. Do you agree? Do you also agree that I could write x to the 0 power next to that? Yes? Okay. In business calculus, we learn a shortcut for doing this computation. We learn a shortcut. Here's the shortcut. It's awesome, but it's not going to make any sense as to why it works. Okay? So you see this here? What I'm going to do is the rule is this. If I see a power of x, I'm going to take that power, I'm going to bring it down in front and multiply. So what would 2 times 5 be? 10? Okay. And then, because I pulled the power down and did that, I want you to subtract 1 from that power. What would you get if you subtracted 1? Just x? Yes? Okay. Now, do it here. Bring this 1 out. What do you get? Negative 2. X to what power? 0. So negative 2, x to the 0. And then here, bring the 0 out, and what do you get? 0. So just plus 0. Okay, what does x to the 0 really mean? 1, right? So this is really 10x minus 2, isn't it? Okay, so come over here. You see this right here? See 10x minus 2? Yes? In business calculus, what we're going to do with this difference quotient is we're going to do all this work, and then we're going to let h go to 0, and that's going to go away, and our answer is going to be 10x minus 2. You see that? So like in business cal, we do all this stuff, we torture you for a while, and then afterwards we say, hey, here's a rule. It's a shortcut, right? And in business cal, we give you those shortcuts pretty quick. In Calculus 1, you have to go through like an entire month or so of torture with this. And you do it for more complicated functions, like trigonometric functions. In here, we don't deal with trigonometric functions at all, like sine, cosine, tangent, if you've ever heard of those. Okay, back to our business. We're done, right? What I boxed up there would be the correct answer for number 8. Okay, looks like we got a lot of word problems now. Okay, number 9, I mean, sorry. Number 9. An employee of a furniture store earns a base salary of $600 a week plus 5% commission on all sales over $5,000. How much must the employee sell in 1 week to earn at least $1,000 for the week? Okay, this should sound familiar from way back in the beginning of class. So let's try and come up with a function that represents this person's pay, all right? So what do you want to call it? Give it a letter here. P for pay? Okay, this person's pay will be equal to what? 600 per week, right? 600 per week, no matter what. They just show up, drink coffee all day, they get 600 a week, all right? Plus 5% commission on all sales over $5,000. We had a problem like this and someone asked about it, and the question was about that over $5,000 thing. So let's take care of the 5% first. How do I write the 5%? 0.05, right? 5% times, right, times the person's sales, right? But not all their sales, only the sales over 5,000. So if they sell $1,000 worth of stuff, they don't make any commission, right? If they sell 4,000, they don't make any commission. If they sell 6,000, they'll make 5% on how much though? Only 1,000, right? So the way I write that in here is I put X minus 5,000. So I'm going to get 5% of anything over 5,000. So, right, if I put in here X is 5,000, I'm not going to make any commission, right? But if I put X is 6,000, I will get 5% of 1,000. Do y'all see it in the formula here? Yes? All right, this is the formula that works. This works whenever X is bigger than or equal to 5,000. What happens if they sell less than 5,000? How much do they make? 600. That's it, no matter what, right? So this formula only works when their sales is over 5,000. Okay, now, but the question is, how much do they have to sell to make $1,000? So how much do they have to sell in order for this pay to be 1,000? So all I'm going to do is replace a P with 1,000, set it equal to 600 plus 0.05 X minus 5,000. And then what kind of equation is this? It's linear. It's a linear equation, right? So how would you solve this linear equation? Linear equations, we isolate x. Isolate x, get x by itself. So let's go ahead first and get rid of the parentheses. Let's distribute 0.05 through. So if we distribute that, get 1,000 equals 600 plus 0.05x minus this times this should be 250. Okay, the next step would be for you to collect like terms. So let's collect our like terms on the right-hand side. I can put 600 and take away 250. That would leave me with 350, right? Y'all understand what I'm doing? Now what? Subtract 350 from both sides. So what would you have on the left side? 650. 650 is equal to 0.05. X. Now what? Divide. What is it? 13,000. That means this person, if they want to make $1,000 in the week, would need to sales would need to be 13,000. They're only going to get commission off of how much of this, though? 5% commission on all of this? No. Only on the sales over 5,000. So how much is this over 5,000? It's 8,000 over. So they're really making 5% on $8,000. What's 5% of 8,000? 400. So their base salary, 600, plus the 400 is going to be the 1,000. All right? Okay, moving on. I hope that looks familiar. You had, I know, at least one homework problem that was like that. Number 10. The revenue function for a product is given. The cost function of a product is given. Find an expression, P of X, for the profit function. So what do you need to know in order to do this? Like what's the relationship between revenue, cost, and profit? What is it? Profit is equal to revenue minus cost. Revenue is the money that you bring in. Cost is, well, how much you pay your employees, pay the electricity, whatever it is. Whatever's left over from that is your profit. So they give you a revenue function. So our profit function, I'm going to write it P of X because its function should be our revenue function minus our cost function. So our profit function, which is what we want, is the revenue function, negative 7x squared plus 832x, minus the cost function, which is 462x plus 35000. Okay. Is that correct? The way I wrote that, is that correct? What's wrong? I need parentheses, okay? Look, this is my cost function. I agree with that. But I'm subtracting the entire cost function, so that has to be in parentheses. Did I have to put my revenue in parentheses? Well, I don't have a negative out front, right? So that doesn't matter. So I don't need parentheses around my revenue. Okay, so my next line will be negative 7x squared plus 832x minus 462x minus 35. Is it 35,000? Yeah. Okay. So let's just simplify this. I can collect some like terms together here. These two together, what's 832 minus 462? 370? Plus 370x minus 3,500, or 35,000. This is my profit function. Okay, you ready? Move on. Questions? All they want you to do is set up what the function is. That's it. What is the profit function? There it is. Number 10. All right, number 10. The revenue function of a... Oh, wait, this is 11, sorry. 11. A manufacturer has fixed costs for a new product, $64,000 with variable costs of $575 for each item produced. So that means my cost function has a fixed cost of $64,000 plus 575x. For every item I produce, it's going to cost me 575 plus the 64,000. Okay, if the item to be sold to its distributors for $12 each, how much must be sold in order to break even? So what's my revenue function? 12x, good. You're going to make $12 for every one that you sell, right? So if this is my revenue and this is my cost, they're asking for the break-even point. What is the break-even point? It's when what? When R equals C, when the revenue equals the cost. So break-even means that revenue equals cost. So what you want to do is set these two equal to each other. So take 64,000 plus 5.75x and set it equal to 12x. What type of equation is this? Linear? So you can just isolate x and solve? Yes? I'm going to put check here. We're done. I mean, you have to do more, but I'm going to let you solve that. That x would represent the number of items that must be manufactured and sold in order for your company to break even. Number 12. A plant can manufacture 70 golf clubs per day for a total daily cost of $8,248, and 100 golf clubs per day for a total daily cost of $11,908. Assuming that the daily cost and production are linearly related, write an equation for the daily cost of producing X golf clubs. What? All right, so what are they really giving us in this problem? This is number of clubs, and this is cost, right? They've told us that they can manufacture 70 golf clubs, and it'll cost $8,248. So if we make 70 golf clubs, it'll cost $8,248. So they've given us a point, haven't they? It's like an ordered pair. They've given us 70 and then 8248. That's 1 point. What's the other point they give us? If we manufacture 100 golf clubs, it'll cost us $11,908. So they've given us a second point. And they are saying assume that the daily cost and production are linearly related. That means assume that there is a line connecting these 2 points. Write an equation for the cost. Yes, good. This is where they want you to come up with the equation of that line. You have to find the equation of that line. And we need 2 things in order to do this. First, we need the slope, which is y2 minus y1 over x2 minus x1. Once we find that, then we use this equation y minus y1 equals m times x minus x1. I know we've done this, okay? So for us in this problem, we get to label our points. We have this point here, 70, and then 8,000 something, and then we have 100, 11,908. So we could call this top one x1, y1, and the bottom one x2, y2, and then we start calculating the slope, and then we plug into this formula. So for my slope, get your calculator out. You're going to do 11,908 on the top here, and you're going to subtract 8248. You get 3660 over, now the difference of the x coordinates, which should be 30 here. Oh, I did the wrong thing here. $122. That's your slope. Then you come to this formula and you write y minus y1, which is 8248, equals 122, and then parenthesis x minus 70. Does this ring a bell? Does that look familiar? Am I done? I should solve this for y. So I would distribute the 122 through. So y minus 8248 equals 122x minus 8540. I will add 8248 to both sides. You getting 292? Anyone that's following along here? Okay, so minus 292. All right, this is your cost function. Right there. I replace y with c of x because the y-axis was our cost. So that answers part A. Graph, well, we've already kind of got the graph, right? So don't worry about part B on that. Okay, I only have 20 minutes. Okay, let's talk about number 13. The cost of producing computer software is a function of the hourly salary paid. The cost function can be approximated with this thing here. What would the cost be if an employee worked 500 hours? So what are you going to do for number 13? There's just one simple thing to do. Plug in 500 for x. That's it. I don't think I'll work through that. You replace all your x's with 500. So you do 0.04 times 500 squared minus 20 times 500 plus 6,000, and you get an answer. All right, let's skip 14. I won't ask you more domain problems. Okay, let's just get rid of those. Number 15, difference quotient. We've already done one of those, haven't we? It's the same thing. It's a quadratic, so that's exactly like the one we did earlier. All right, number 16. F of x equals x squared minus 4x minus 5. All right, part A. Find the vertex. How do you find the vertex? There was a formula. Remember the vertex is a point HK? This is a parabola. This is that section about graphing parabolas. So the vertex was the point HK. How do you get H? Anyone remember the formula? Negative B over 2A. There you go. Now, B for us in this problem is what? What's B for us in this problem? Negative 4. So when we do negative 4, it's going to actually turn into positive 4. So we have positive 4 over 2 times what's A? In this problem? The 1, right? It's in front of the x squared, so 2 times 1. Don't know why I wrote that. 2 times 1, which is just going to give us 2, isn't it, when it's all said and done? That's what H is. How do you get K? Plug it into the function. So to get K, we replace our x's with 2. So 2 squared.